Okay, today I'm going to give you a quick review of two kinds of factoring that you should have learned last year, and then show you another kind of factoring that you may or may not have learned last year. And all of them are fairly straightforward and pretty easy, okay? So the first kind of factoring that we're going to do is called GCF, or factoring out the greatest common factor. And it's usually not very hard, so let me just give you a couple of quick examples. All right, this is a binomial. It's got two terms, and each of the terms is composed of different kinds of factors. There's a numerical factor here. There's a factor that contains x's, and there's a factor that involves y. And we're going to look at those each separately. So what we're looking for is the single largest value that divides evenly into 8 and 6 with no remainder. In other words, what's the greatest common factor for 8 and 6? And that is 2. We're also going to look for the greatest common factor of x cubed and x, and the easiest way to do that is you just pick the one with the lowest exponent. That's all you have to do, so it's going to be this one, x, right here. We do the same thing with the y factor. We're going to look for the greatest common factor for y and y cubed, and again, you pick the one that has the lowest exponent, so we're going to pick y. This number right here, this term right here, is called the greatest common factor, 2xy. Then we're going to put parentheses. I'm going to see what is left if we factor out or divide by the 2xy. And the long method is for you to think, I'm going to take the original problem, this piece up here, 8x cubed y, and divide it by 2xy. Practically, you don't actually have to write that down. You're simply going to divide 8 divided by 2 is 4. X cubed divided by x, you can subtract the exponents, x squared, and y divided by y cancels to just 1, and so you don't have to write that down on the inside because you're dividing. Okay? There's a minus. The minus comes from here. This is plus, you put a plus. If that's minus, you put a minus. And you do the same thing for the second term, this here, 6xy cubed, and you are also dividing it by 2xy. You're going to divide it by the same thing. And again, you don't have to write this step down. 6 divided by 2 is 3. X divided by x is 1. 3 times 1, so you don't need to show the 1. And x cubed divided by, y cubed divided by y is, subtract the exponents, y squared. Okay, this is called factoring out the greatest common factor. And this step here, this is brain work. You can do this in your head. But if you ever get stuck on one, if I ever do one that's a little funny, you can backtrack and do it by this division method. All right, that's the first one. The next two I'll show a little bit less work on. Okay? If there is more than 2 terms, if there are more than 2 terms, then your greatest common factor has to be a factor for every single term. So this time I need a number that divides into 3, 9, and 6, and that's going to be 3. My next factor involves x's. There's an x cubed, an x squared, and an x. You pick the one with the smallest exponent. So my GCF, my greatest common factor, is 3x. There were 3 terms to begin with. When I get on the inside here, there are going to be 3 terms, 1, 2, 3 on the inside as well. Okay? And you're going to just do division. This 3 divided by 3 is 1. And x cubed divided by x is x squared. 9 divided by 3 is 3. And x squared divided by x is x. And 6 divided by 3 is 2. And x divided by x is just 1, so I don't have an x term on there. Another way of thinking about this is backwards distributive property. The answer that you get looks like a distributive property question, and you can check your answer by doing distributive property, whether you write it on paper or you just think it in your head. 3x times x squared is 3x cubed. 3x times 3x, 9x squared, and 3x times 2, 6x. And just make sure that you watch your signs. Remember, if it was a minus, it stays a minus. If it was a plus, it stays a plus. I'm not gonna do these with really super hard GCFs. They should for the most part, be GCFs that you can do in your head. So you mostly need to watch out for careless types of mistakes, things like 3 times 3 is not 6, that kind of thing, okay? And this one is, in particular, this is the last one of these. The GCF here, the biggest number that divides evenly into 4 and 4 is, of course, 4. And then we have an x squared and an x, pick the one with the smallest exponent, and that's x. It's really easy here to make a super careless mistake. When we say 4x squared divided by 4x, we get x. And when we say 4x divided by 4x, some people think, oh, it's gone, but you have to remember you're doing division. So 4x divided by 4x is 1, and you have to put that 1 there, or else it wouldn't be right. If you just left it as 4x, and you just put an x in here, this does not equal what we started with, whereas this answer is equal to what we started with, right? There's your GCF examples. The second kind of factoring is called difference of 2 squares. Difference of 2 squares. And they all look exactly alike. There are 2 terms with a minus in between them. That's the difference of 2. And each of the terms is a perfect square. So x squared minus 9 qualifies as this. You would not see this as a difference of 2 squares because 10 is not a perfect square. There are things you can do with that, but they don't quite fit into this category for right now. So we will not be doing that difference of 2 squares. And difference of 2 squares factor into a binomial times another binomial, one with a plus, one with a minus. Hopefully y'all remember this. One with a plus, one with a minus. These 2 terms right here have to be the same terms, and they have to multiply to give you the first term there, x squared. So that's going to be x and x, easy enough. These 2 terms also have to be the same. Okay, you can't put 9 and 1. You have to put the same number there, and they have to give you this right here. So basically, you're doing what is the square root of 9, and then the answer is 3, and those 2 go right there. So when I ask you to factor x squared minus 9, it factors these 2 terms, x plus 3 and x minus 2. That's the answer. You may look at this and think, well, that looks like a FOIL question. You're right. This is backwards FOIL, and it's a special kind of FOIL that results in this difference of 2 squares. If you did FOIL on this, if you used FOIL for this, you would in fact get this answer. Okay? All right, that's the first one. The second one, 4 minus 25 m squared. So in order for it to fit in this category, it has to be a difference. It is. Only 2 terms, 1, 2, and everything in this needs to be a perfect square. 4, the square root of 4 is 2, 25, the square root of 25 is 5, and m squared, the square root of m squared is m. So this is difference of 2 squares. 2 binomials, 1 plus, 1 minus. This number right here is going to be the square root of 4, which is 2. Put it in both places. This number right here is going to be the square root of 25, which is 5. Put it in both places, and don't forget to put the m. Okay? And there's your answer. 2 plus 5m, 2 minus 5m. So these are super easy problems as long as you recognize them. Okay? 36 squared minus 49 y squared. Difference minus both exactly 2 terms, binomial terms, and the square root of 36 is 6, and the square root of 49 is 7. So this fits into our table. 2 binomials, 1 plus, 1 minus. If you wanted to, you could put minus and plus. This doesn't make any difference. I usually do plus and minus, but it's the same thing. So this first one right here is the square root of 36, which is 6. And don't forget the x. And you have to put the same thing here, and 6x. You can't put 9x and 4x for this kind of problem. It doesn't work. The second one is square root of 49, 7y, and 7y. And just again, if you were to FOIL this out, if you took this and did FOIL and multiplied it all out, it would take you back to this problem right here. All right, last one. 16x squared minus 1. Sometimes people miss this one. They don't recognize it because of that 1, but 1 is a perfect squared, the square root of 1 is 1. So this is going to fit into our structure. The square root of 16 is 4. Don't forget your x. 4x, 1 plus, 1 minus, and the square root of 1 is 1. And there is your difference of two squares. Now you should have seen both of those kinds of factoring in Algebra 1. Hopefully you remember them. And this was just a reminder. Okay. This next kind, sometimes Algebra 1 teachers do it, and sometimes they don't do it. And there's actually two of them. It's called sum of cubes or difference of cubes. I should say 2 cubes. Sum of 2 cubes, or difference of 2 cubes. And before I show this one to you, this is a memorized formula. Before I show this to you, I want to remind you of some things that you need to have memorized. You need to know a few perfect cubes. You need to know that 1 cube is 1. You need to know that 2 cubes is 8. You need to know that 3 cubes is 27. You need to know that 4 cubes is 64. And you need to know that 5 cubes is 125. Okay, these are the only 5 that I need you to worry about for right now. If there are any others than this, we'll worry about that a little bit later on. These 5 I need you to start memorizing now, just like you know that 8 squared is 64. I need you to know that 2 cubed is 8. These need to go into your memory bank. Okay? This is a memorized formula, and I'm going to do it first with difference. Do it first with difference, and it looks like this. I'm going to use A and B. A cubed times B cubed. This is a difference of 2 perfect cubes. Okay, so this is a pattern that we're going to follow. And the way that you factor the difference of cubes is you're going to have a binomial and a trinomial. In this binomial, you're going to take this base and this base. A minus B, and that sign, whatever it is, right there, the minus goes right there. Okay, A minus B. And then in this one, you're going to have a trinomial. You're going to have 2 pluses in it. The first term here is whatever this was, you square it. A squared. Whatever this one is, you square it, you put it in. B squared. And then you have a term in the middle. And the term in the middle is simply these 2 things multiplied together. Pay no attention to the negative, just the 2 terms, A times B. Okay? So we have a structure to memorize. If we have this structure, then the answer is this structure. And the biggest thing is memorizing this sign pattern. Right here. So let me show you how this works. Okay? So we'll do x cubed minus a. The numbers that are going to show up in these problems will be these numbers. This. Those are the numbers that we're looking for that tell us that we might be looking at a difference of 2 cubes. Okay, so the difference between an x cubed and that's a 2 cubed. So we know that we're going to have the right structure, a binomial and a trinomial. I like to get my signs in first so I don't forget them. If this is a minus, this is a minus, and the other 2 are plus. Okay? You need your bases here. This base right here is x. This base is not 8, even though that number is 8. You have to think of that 8 as a 2 cubed, and the base you're going to use is 2, not 8. All right? Once you get that set, then the rest of it's pretty easy as long as you get it memorized on your first homework. Keep looking at the formula so you don't miss anything. You're going to take this term right here, this x, and square it. You're going to take the 2, this 2, and square it. And then you're going to take these 2 and multiply them together, and that goes in the middle. Okay? It isn't hard, but it is something that you have to memorize. All right? Let's look at this one, 27x cubed minus 1. Okay? Again, there's that number 27 that's on that list I told you at the beginning. It's an x cubed, and there's a 1 that's on that list. So binomial and a trinomial. Minus 2 pluses. Okay? In this case, this is the easy one right here, 1, because 1 is 1 cubed. So I get to put a 1 here. Okay? have to look at this part right here, 27. Think about what is cubed to give you 27, and that answer is 3. So you take that base, 3, and then you get your x. Once you get that binomial set, you're going to memorize what goes on the other end. So you're going to take 3x and square both the 3 and the x, so it becomes 9x squared. You're going to take 1 and square it, and then you're going to take these two numbers and multiply them together, and 3x times 1 is 3x. And that is how you factor by difference of cubes. The last one is sum of cubes. And it looks almost the same. Instead of a cubed minus b cubed, it's a cubed plus b cubed. The good news is it's similar to the other one. If this one's a plus, this is a plus. The bad news is it's so similar we sometimes get them mixed up. But again, you just have to memorize it. This sign pattern is a minus and a plus, so you need to memorize the sign pattern. Other than that, it's exactly the same. There's no difference in this one and the other one. The only difference is the sign pattern. So when this is plus, you have a plus here, minus, and a plus here. Okay? All right, so let's work a couple of these. Cube plus 64. This is on that list right there. The 64 is one of those cubes. Binomial times trinomial. This is plus, minus, plus. Get that sign pattern. This is n cubed, and this space is n. This is 64. Don't put 64 here. You have to go up and remember that 64 is 4 cubed. And so what goes right here is 4. And after that is exactly like the last problem I showed you. You take it down and you split it. You take the 4 and you split it. You take the m and the 4 and you multiply them together and they go right here. So if you can do sum of cubes, you can do difference of cubes. If you can do difference of cubes, you can do sum of cubes. And the biggest thing is not getting them mixed up and memorizing things badly. Okay, last one. Okay, this is a sum of cubes. Remember that list I gave you back at the beginning. You got 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And both these numbers, 27 and 125, are in that list of things you should start memorizing. Binomial, trinomial. The sign pattern goes in next. Plus, minus, plus. What do we put? If that number is 27, we need the correct base for it, and the correct base is 3. Don't forget your x. This number is 125. The correct base for that is 5, and don't forget your y. Okay? When you go to the next set of parentheses, to that trinomial, you take this whole base, 3x, all of it, and square it. 9x squared. You take the whole base, 5y, all of it, and square it. 25y. And then you take these two numbers and multiply them together, and you get 15xy. Okay? So, for homework tonight, you're going to have a worksheet. It's posted on, look at your email for me, and it will tell you exactly where it's posted. I may attach it to the email. And it's just these problems, GCF problems, difference of squares problems, and sum and difference of cube problems.